Machine learning, a cornerstone of artificial intelligence, wields the power to transform vast amounts of data into actionable insights, driving innovation and decision-making in every sector of society. But how does one harness this power? The answer lies in understanding the workflow of machine learning. Embarking on a machine learning project begins with the critical step of data gathering. This phase sets the tone for the entire process, as the quality and quantity of data collected directly influence the effectiveness of the predictive model. If the aim is sentiment analysis, for instance, valuable data might be gleaned from social media platforms. Once data is gathered, the next stage is data preparation. This involves loading the data into an appropriate location and preparing it for the training process. The data is randomized to ensure the learning process isn't affected by the order in which the data was originally presented. Data visualization comes into play at this stage, revealing potential relationships between variables and highlighting any data imbalances. Data preparation may also require adjustments such as deduplication, normalization, and error correction. Another crucial part of this phase is dividing the data into two segments. One for training the model and the other for evaluating its performance. With the data prepared, the focus shifts to model building. This involves selecting an appropriate algorithm from the many available, each with its strengths and weaknesses. The choice of algorithm largely depends on the specific problem at hand. Training is the subsequent step in the workflow, often considered the most vital. The model incrementally improves its predictive capabilities through exposure to the data. For instance, it may learn to distinguish an apple from an orange. After training comes the evaluation phase, where the model's effectiveness is assessed using the previously set-aside data. This step helps gauge how the model might perform against unseen data, essentially providing a glimpse into its potential real-world performance. Evaluation metrics such as classification accuracy, confusion metric, mean absolute error, and mean squared error can be instrumental in this process. Following evaluation, there's an opportunity to fine-tune the model by adjusting certain parameters like the number of times the training set is run through or the learning rate. This stage underlines the importance of defining what constitutes a good model to avoid getting stuck in a loop of endless tweaking. In summary, machine learning leverages data to make predictions, substituting human judgment and manual rules with a model. The workflow, from data gathering to model tuning, is a systematic process that ensures the power of machine learning is harnessed effectively. Remember, the strength of a machine learning model lies not just in its predictive capabilities, but in the quality of data it's trained on and the appropriateness of the chosen algorithm. Until next time, keep exploring the fascinating world of machine learning.